Hello everyone, and then welcome to another video. Okay, so in this video we'll be treating the most simplest topic you would ever meet in applied electricity. Okay, so bear that in mind, that impedance is the most simplest topic or subtopic you will ever meet in applied electricity. Okay, so without further much ado, let's just dive into this video. So in case you are new to this channel, kindly subscribe. Okay, subscribe and then hit on the bell icon so that you don't miss out on any uploaded video. Okay, like the video and then let me know whether you have any questions in the comment section. I will reply to them as soon as possible. Okay, so let's just dive right into this topic. Okay, so impedance. Okay, so when you talk about impedance, it's all about what? Opposition to what? Current flow in AC circuits. Okay, we try to oppose current flow in AC circuits. Okay, so for impedance, okay, we have what? The inductance. Okay, that's the opposition to what? Inductance. Okay, that's the X subscript L. Okay, and then we have what? Opposition to what? Capacitance. That's the X subscript what? C. Okay, we have superscript and then subscript, but these are what? Only subscripts. Okay, so right, in this video I'll be just treating the most salient formulas you need to know. Okay, there's no need for you to learn everything. Okay, I will pinpoint the only salient formulas you need for this what topic. Okay, else you might be learning other stuff which aren't important. Okay, right, so let's dive right into that. So first, you need to know the general formula for what? The opposition to inductance, and then what? Opposition to what? Capacitance. Okay, so for opposition to inductance is what? 2 pi FL. Okay, and then the opposition to what? Capacitance is what? 1 over 2 pi FC. The C is the capacitance. Okay, it is always or sometimes given in a question. Okay, now there is one thing you need to know. Okay, there is something we call lag and then leads. Okay, so whenever we talk about lagging, it means that something which is behind. Okay, and then whenever you talk about leading, and then it means that something which is far ahead. Okay, so for capacitance, okay, for capacitance, the currents in the capacitance always leads the voltage by what? 90%. Okay, and then for what? For inductance, the current in an inductance always lags the voltage by what? 90%. Okay, these are some things you need to keep in mind, that for inductance are always lagging. The currents are always lagging the voltage. Okay, and then for capacitance, the current are always what? Leading the voltage. Right, let's move on to the most important portions of what? Impedance, the topic impedance. Now we are about to look at the impedance of what? Circuit arrangement. Okay, so we normally take impedance for only series arrangement. Okay, right, so for series arrangement we have what? The resistance and what? There's the inductance. Okay, the resistance and then inductance. Right, so for resistance and then inductance we have this circuit arrangement. Okay, so we have a certain current coming in from the voltage source, and then it meets at a certain resistor, and then a voltage across that resistor, and then we have a certain inductance, and then the voltage across that inductance. Okay, so when you use a simple calculation approach, you end up with what? Something like a Pythagoras expression. Okay, so we have the V squared equals what? The V subscript R squared plus the V subscript L squared. Okay, and then we know that the V according to Ohm's law is what? The current and then the what? The resistance. Okay, so we have this expression IR squared. Okay, and then the same thing applies over here. So these are the salient formulas you need to know for what? Series arrangement for R and then L. Okay, the resistance and the what? Inductance. Okay, right, so you need this formula, and then the inductance formula, very very important, and then finding the phase angle for the what? The resistor and then the inductance. Okay, that's also very very important. And then the other point, okay, is that for series arrangement for resistor, and then what, inductance. The current in a series arrangement for what, the resistor, and then what, inductance circuit always lacks the voltage, but not by what, 90%. Okay, so you know that for inductance the current is always what, lagging. Okay, and for what, capacitance the current are always leading the voltage. Okay, but for series arrangement for what, resistor, and then what, the inductance, even though the current lacks the voltage, okay, but it's not by what, 90%. Okay, right. So these are the formulas you need to know. Okay, so we've got to know these two salient formulas. Okay, and then we moved on to what, the series arrangement. You got to know these four formulas, but for these four formulas, these are the main two you really need to know. Okay, even though you need to know all the four formulas. Okay, so this second formula could be rightly derived from the first formula, so I will say you need only these three formulas. Okay, 1, 2, and then 3. Okay, so now let's move on to what, series arrangement for what, the resistor and then capacitance. Okay, the same technique is being applied. Okay, so you have a voltage, the voltage with what, subscript R, and a voltage with subscript C, that's the capacitance. And then from Ohm's law we got to derive this. Okay, and then for this arrangement you need what, this formula, and then this formula. Okay, most importantly. Okay, so we know that Z, just like what, inductance is what, R squared plus what, X subscript what, L squared, or what, in that form. Okay, and then we have the square root of what, just as this raised to that square root. We also have what, the series arrangement for what, resistor and then capacitance. Okay, their impedance also is, we take the square root, okay, of the resistance squared. Okay, and then what, the X subscript C squared. Okay, and then we take the phase angle, okay, tan inverse of the capacitance, okay, the opposition to capacitance, and then divided by what, our resistance. Okay, again these are the three formulas you need to know. Okay, the three main formulas as we were able to derive over here. Okay, the three main formulas. Okay, you need to keep in mind, very, very important. Okay, again for capacitance we know that they always lead the what, the current lead the what, voltage. Okay, same thing applies, the current leads the voltage in what, an RC circuit, but not by what, 90%. Okay, keep that in mind. Now let's look at the combination of all the three. Okay, so for combination of all the three we have this simple circuit. Okay, right, and then we have what, our impedance. Okay, so for all the three, this is how the impedance will look like. But let's first look at the what, the Pythagoras arrangement. Okay, so we have V squared equals what, V subscript R squared plus what, V subscript L minus V subscript C, all raised to power squared. Okay, so the impedance will be the square root of the entire R squared plus what, S subscript L minus X subscript what, C, all squared. Okay, so this is being taken into consideration. This formula is also being taken into consideration. Then we have what, phase angle. Okay, being taken into consideration. Now we've got to know the main formulas you need for what, impedance. Okay, these are the main formulas you need for impedance. Okay, so these are first formula, second formula, okay, third, fourth, fifth. Okay, that's for series arrangement for R and L, resistor and then inductance. Okay, we want to these three formulas. Okay, that's for what, resistor and capacitance, and then you move on to what, the combination of the three. Okay, now let's take an example. Okay, let's take an example in order to what, help us understand what the topic. Okay, so let's say we have this question. Okay, so now we've been given a certain question. Okay, we have what, a coil has a resistance of what, 12 ohm, and then inductance of what, 0.1 Henry. Okay, So H is what? Package H is what? Henry, okay? And then it is connected across 100 volts, 50 hertz supply, okay? And then we have to calculate what? Reactance and what? Impedance of the coil, the current, and then the phase difference. This question is actually very simple, okay? So let's look at how we go about this solution. First, you need to write out all the parameters you've been given, okay? Write out all the parameters you've been given, okay? So we've been given what? What resistor, okay? So I have a resistor to what? 12 ohm. We have our what? Inductance to what? 0.1 Henry, okay? We have our voltage, okay, to what? 100 volt. So first we have to calculate what? The impedance, okay, of the coil, okay? So in general we know what? This formula, okay? Right. From here, okay? So you know these formulas, okay? Right. This is what? Series arrangement for R and L. So let's try draw this what? Circuit arrangement, okay? Let's see whether we could be able to draw this circuit arrangement. It's very simple, okay? So we have what? Our coil, okay? This is our coil. And then we have what? A certain current coming in with our resistor, okay? And then we have what? Our inductor, okay? Right. So we have an inductor of what? 0.1, resistor of what? 12 ohm. We have our current, okay? We have 50 hertz, okay? And then we have our voltage source of what? Voltage source of 100, okay? Coming in, okay? Right, so we have a certain VR, and then we have what? VL, and we have what? XL, but we already know what? We've been given only what? L, okay? That's 0.2. Okay, so let's see how we go about this solution, okay? So first we know what? We know that XL, okay, is equal to what? 2 pi FL, okay? Yes, we can record that from this formula, okay? The first formula, okay? Right, this formula, okay? Yes, that's where we can find what? Impedance, okay? Right, so we have this formula, okay? So we already know what? Our inductance, okay? So we have 2 pi times what? Frequency of what? 50, okay? Times what? 0.1, okay? So this will give us what? When you compute this, you end up with what? 31, okay? 0.41 maybe. 42 or 416, okay? And then this is measured in what? Ohms, okay? So now we calculate our what? Our impedance, okay? Right, so let's see. So we have what? Our impedance to be equal to the square root of what? R squared, okay? Plus what? XL squared, okay? So this is the same as what? Let's take our square root of what? We know our resistor to be what? 12, okay? 12 squared, and then we know our what? XL to what? 31.416, okay? So I have 31.416 squared, and this will give us what? When you compute this, you end up with what? 33.6, or let's say 63 ohm, okay? You see how simple this is, right? So let's see. Let's move on to B, okay? Let's see how we can solve for B, okay? So we have to find what? The current, okay? So let's see how we can find what? The currents. Right, so let's see how we can calculate the current. So we have, note that although we know that V is equal to what? IR, okay? But you are working with what? Impedance, okay? That's why the question at first told us was find impedance. So instead of resistance, you can just substitute this into what? Our impedance, and then find out what? Current, okay? Okay, so we have our voltage. We know that we've been given our voltage to what? in the question we are given voltage to be 100, and then we already know our impedance, okay, to be what, 33, okay, 0.63, okay. So most definitely when you compute the value for current, you end up with what, 2.9, okay, 2.97, okay, let's leave it at 97 or maybe 974, okay. 3 decimal place. Always leave your answers in what, preferably 3 decimal places, okay. So this 2.974 amps, okay. Now we've been told to find what, the angle, okay. So from the question, this was our current, okay. So we are told to find what, the phase angle, okay. And then we know that from here we know that there's a formula for finding what, the phase angle. So we have what, our theta to be equal to what, tan inverse of what, XL on what, the resistor, okay. So let's proceed. So we have the tan inverse, okay, of XL, okay. And then remember that we had XL to what, 31.416, and then we know our resistor to be what, 12 ohms, okay. So let's compute for the angle, okay. So the angle is what, 69.09 degrees, okay. Yes, so this brings us to the end of this tutorial video, okay. I hope you enjoyed this video and then you were able to understand and grasp the concept of what impedance, okay. Again, impedance is the simplest topic you will ever meet in applied electricity, okay. So try to understand the formulas, okay. As I already stated in my AC circuit tutorial video, the first video, I told you or revealed to you that you already need to know what the formulas in AC circuits. That's it. It's not like the direct current circuits where you need to apply what certain concept, okay. For AC you need to know the formulas, okay. Once you know the formulas, you are good to go, okay. Thanks for staying with me to the end of the video. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that it gets pushed to other students like you who might need these videos to help with their academics, okay. Kindly like the video and then let me know your questions in the comment section, and I'll see you in the next video. Bye bye.